8.3, partitioning line segments. When we're partitioning line segments, we're looking for a particular point that splits the line segment and the two endpoints into a particular given ratio or in a particular way. We have the following steps to find this particular special point. Step 1 is to determine the fraction of the distance you want to move away from the first point. This could be given, or most of the time you'll be given a ratio, and you'll need to convert that ratio into a fraction of a distance. Step 2, determine the distance between the two x-coordinates. You can do this by taking the second coordinate, take away the first coordinate. Order does matter. Notice that you're always taking the second coordinate minus the first coordinate. In step 3, you're going to multiply the two values that you found in steps 1 and 2. Then, finally, you'll add that value to the x-coordinate. Last but not least, you're going to repeat this entire process, but for the y-coordinates. So let's take a look at our problems. In problem 1, we're given 2 points, A, -2,4, and B, 1, -5. And we want to find the coordinate P on a particular segment AB that's going to partition the segment into a ratio of 2 to 3. Visually, this is what it looks like. You have a segment, and it's split at a particular point such that there are 2 points on the left of this particular point and 3 parts on the right. And I should mention that these parts should be equal. My picture isn't that great, but ideally each of these partitions would be exactly the same distance. So this is your essentially 2 to 3 ratio. Now, this is not the distance that I'm talking about in step 1. The distance is the actual fraction of the entire length away. A ratio just tells you how many parts on the left to how many parts on the right. So, let's talk about how far away we want to go. We have 5 total parts, and we want to go to the end of the second of those 5 parts. So we're looking to go 2/5 of the way. Another way to think of this is that the first number in the ratio gives you the numerator, and if you add the 2 numbers, that gives you the denominator. So it's the first number over the sum. And this will be the distance from the first point. So 2/5 of the way. Our second step is to find the distance between the x-coordinates. So the first thing I'm going to do is list the points. And you don't necessarily have to do this, but I just want to kind of show you what's going on. You don't have to do it this way. So here are our x-coordinates, -2 and 1. We want to find the distance between these. To do this, we're going to take the second x-coordinate, 1, and subtract the first x-coordinate, -2. So 1 minus -2 is a +3. So here's our distance. What we've calculated here is essentially how far we would have to travel from A to B in our x-coordinates. The next step is to take the fraction of the way and multiply it by the distance. This is going to help us calculate our new x-coordinate. So I'm going to take 2/5 times our +3. In doing this, we're essentially finding how much is 2/5 of the whole distance, because this is the distance that we want to travel. We don't want to go all the way 3 units. We only want to go 2/5 of that entire distance. So we're going to multiply 2/5 times 3. When you multiply fractions, don't forget, you're going to multiply across the top and multiply across the bottom. If you have a single integer, this is like the number over 1. So 2 times 3 would be 6, and 5 times 1 gives me 5. So we're going to travel 6/5 of the way. However, that's not going to be our final coordinate. That's how far we want to go away from the original coordinate. So we also have to add the original x-coordinate, -2, to find the final position. So 6/5 plus the original position will be our answer. When you're adding fractions, if you're doing this by hand, you want to make a common denominator. So, negative 2 is the same thing as negative 10/5. 6/5 plus 10/5, and I'm sorry, I don't know, I just noticed that this was a negative when it shouldn't be. Miscopied that. So positive 6/5 plus negative 10/5 gives us a final x-coordinate of negative 4/5. And this will actually be the location of your new x-coordinate. All right, so we're going to repeat the same process, but for the y-coordinates. So the distance will remain the same, 2/5 of the way, because our y-coordinate should also be 2/5 of the way. Currently, the distance between our y-coordinates is going to be negative 9. You can get this value by taking the second y value, take away the first y value, so negative 5 minus 4. Now, it's very important that you keep that negative sign with it because you're actually going in the downward direction. So that's very important in our problem. Next, we're going to take the fraction 2/5 that we want to travel and multiply by the entire distance of our y points, so negative 9. And once again, what you're doing in this particular part of the process is you're finding the actual physical distance that you want to move away. We want how far of the entire negative 9 units do we need to travel if we just want to go 2/5. When you multiply this, you get negative 18/5. And again, this is just how far we want to go, not the actual coordinate. So we have to add the original y coordinate 4 to get our final y value. Once again, I need common denominators. So I'm going to change the 4 into fifths. 4/5 would actually, 4 in fifths would be 20/5. And adding negative 18/5 plus 20/5 gives me a positive 2/5. So that's my new y coordinate. This gives me an overall point of negative 4/5, comma 2/5. And this would be the location of my new point. All right, so let's take a look at problem 2. Now, if you just read problem 2 very quickly, it appears that it looks like it's the exact same problem as number 1. But if you actually read carefully, you'll notice that the way it's written gives us some information in a different way. A and B are clearly the same exact points. However, the point that we want to find is not a ratio of 2 to 3. It's 2/3 of the way. So they actually gave you the distance in the problem. So step 1 is done for you and not necessary. Just visually, I'm going to show you what we're doing. This time we're finding the point that is literally 2 out of 3 segments away. So we're finding this coordinate right here in between A and B. The ratio for this would be actually different. It would be 2 to 1 because we have 2 parts on the left to 1 part on the right. But since they gave us the fraction, that's the one we're going to use, 2/3 of the way. Once again, we don't want the ratio. We want the distance, the fraction of the distance away that we desire. So 2/3 of the way. So that was given to us. That's nice. And once again, in our second step, I'm going to go ahead and list both coordinates, although you don't necessarily need to lay it out this way. And I'm going to find the distance away from my x, and I'm actually going to do the y in this problem at the same time. So what is the distance between negative 1 and 1? Well, 1 minus negative 2 gives me a positive 3 again, and negative 5 take away 4 is negative 9. Notice that the distance between the 2 points remains the same because the points are the same. Okay? Moving on to the last step, finding our new coordinates by multiplying the 2 numbers and adding the original values. So for our x-coordinate, we want 2/3 of the entire positive 3 distance. Multiplying, I get 6/3 or 2. So what that tells me is that I want to physically move 2 units in the x direction. But that's not my position, that's just how far I want to travel away from the original point. So I need to add the original x coordinate to find my new location. 2 plus -2 gives me a new position of 0. We'll repeat this for y. We want 2/3 of the way. The y coordinate is currently -9 units away. So 2/3 of -9, if you multiply, gives you -18/3 or -6. So I want to move 6 blocks in the downward direction, or -6 y blocks. And that's how far I want to move, but again, it's not the position. I have to add that to the original position to figure out what my new position is. In this case, -2. And that's my coordinate. 0, -2. Let's move on to problem 3. Looking at number 3, it actually appears to be the same as number 1 again. In fact, number 3 looks even closer to number 1 than number 2 did. We have the same points and the same ratio. However, there's one minute detail which changes everything, and that's this segment name, BA. This time we're not partitioning A to B, we're partitioning B to A. So it changes the order of our points, and it will actually completely change our answer. Visually, it's the same thing. We're finding the particular portion which is going to split the segment into 2 parts on the left to 3 parts on the right. But instead of going from A to B, this time we're going from B to A. So that particular partition is going to be closer to B rather than A. If you look at the first picture, these points are swapped, and the particular point from part 1 would be closer to A. Our fraction is going to be the same as problem number 1, 2/5 of the way, because we want the second partition out of the 5 partitions total, so 2/5. However, our second step is where the difference comes into play. We're not starting at A, we're starting at B, so that's the point I'm going to list first. And then I'm going to go to A, so that's the second point that I'm going to list. To calculate my distance, I'm going to take the second x value, in this case -2, take away the first. -2 minus 1 gives me a -3 distance. So notice this is the exact opposite of problem 1 because we're going in the opposite direction. Our second y coordinate is 4, and we're going to take away -5, giving us a +9 difference in our y's. In our last step to finding our new coordinate, we're going to multiply the fraction, 2/5, times the entire length. So for our x's, that's going to be -3. 2/5 times -3 will be -6/5. So this is going to be the physical distance that we want to move. It represents 2/5 of the entire distance that already separates these 2 points. And we're going to add this to our x coordinate from our first point, in this case, the bx coordinate, 1. I'm going to do this rather quickly, the math here. So I'm just making a common denominator and adding the fractions to get a final x coordinate of -1/5. Let's go ahead and calculate our y coordinate. We want 2/5 of the entire y distance, +9. Multiplying these, we get 18/5. This is our physical distance that we want to move away from our our y coordinate. This time we're going to move away from -5, our y coordinate of b. Again, I'm going to quickly go through the math here, making a common denominator. -5 is -25/5. And adding our 2 fractions together by adding the numerators, I get -7 on top over our common denominator 5. So negative 7/5. So our new point is going to be negative 1/5, comma, negative 7/5. Note that this is a different point from 1, and that's because we're finding the point from B to A rather than from A to B. So that's why there is a difference. Okay? All right, let's take a look at our last problem. Midpoints. Here we have the same set of points again, but this time we want to find the coordinates of the midpoint. So let's talk about what that visually looks like. If we have a segment and we're looking for the midpoint, we're just looking for the point right directly in the middle. So what fraction of the way are we going? Well, we're going half of the way. By the way, if you wanted to find the ratio, that would actually be a 1-to-1 ratio because there's one part on the left to every one part on the right. Let's find the distance between our x and y coordinates. Since we're going from A to B, our first coordinate is A, and our B coordinate is 1, -5. By the way, it didn't necessarily say from A to B or B to A. For a midpoint, it doesn't matter because the middle should be the same point no matter what direction you're going to take it with respect to. Okay, so our x distance is the second x minus the first. So 1 minus -2 is +3. -5 minus 4 gives me a -9 for my y's. All right, let's find that x coordinate by multiplying the fraction. 1/2 times the distance, 3. So 1/2 times the total distance gives me 3/2. So I want to move 3/2 away, but I have to add it to where it currently is, -2. Moving 3/2 plus the -2 that we started with will give us, if we make common denominators here, -4/2, give us -1/2. So that's our new x coordinate. Let's go ahead and quickly find our y coordinate. 1/2 of the total current distance away from our y's tells us that we need to move -9/2. And we need to move that away from our current y position, 4. So we're going to add that 4 to it. Converting our 4 to a common denominator, 8/2, we get -1/2 when adding the two fractions. So our x and y coordinate happen to be the same. They're not always going to be the same, they just happen to be the same in this particular example. So there is our midpoint of this segment. Now, I showed you that using this process you could get the midpoint, but there's actually another way you can find a midpoint, and that's using the good old midpoint formula that you learned back in the day, either in middle school, algebra, my class, wherever you saw it for the first time. The midpoint formula, if you recall, is x1 plus x2 divided by 2, comma, y1 plus y2 over 2. If we calculate this formula for both the x and the y coordinate, we should find the same exact point. So let's go ahead and do that. Our x1 and y1 are the two x coordinates of the point, so -2 plus 1. And we're going to divide it by 2 according to the formula. Next, we're going to add our y values, 4 plus -5, all over 2. If you simplify each of the coordinates, -2 plus 1 gives us -1 over 2. And our second coordinate for our y coordinate, 4 plus -5, we get -1 over 2. So if you notice, our coordinate happens to be the same. So what I'm showing here is that you can use the longer process and get the midpoint, or you can use the midpoint formula. You pick whatever's easiest for you. The problem with the formula, although it's quicker, is that you have to memorize the formula. Unfortunately, the midpoint formula isn't always given on standardized tests. So if it's given, that's great, you can use it, but if it's not given, you have to rely on memorizing that formula. Myself, I don't like to memorize formulas. I like to do processes because they make sense to me. But if you find it easier to memorize the formulas, then you can do it that way, by all means. All right, one last thing that I want to talk about. So finding a partition can actually be done with a formula. Some people stress the formula, but this year I really want to focus on the process that I showed you earlier, because once again, the formulas aren't always given on standardized tests. I know last year on the air test, this formula was not provided. So if students didn't have it memorized, then it was more difficult for them to actually find the correct answer. So yes, formulas might be quicker, but they're not always useful on those standardized tests. And that's why I really, really stress the process above. It may be longer, it may take a little bit more time, but it makes sense why you're doing each of those steps, and it's probably going to be the one that you're going to memorize or be able to duplicate more than a formula. Because if you mess up one little detail in that formula, the whole answer is wrong, unfortunately. So I just want you to see it, and if you want to use it in class, I'd be happy to demonstrate it with you individually or as a group. But here's the formula. It actually this time uses a ratio instead of the fraction of the distance. So we would want to convert any of those fractions of the distance to ratios. So it uses the ratio m to m, and we have the 2 points x1, y1, x2, y2. And to calculate the coordinate, all you're going to do is plug the numbers in the appropriate spot. So you would take the m value times the second x coordinate plus the n value times the first coordinate all over the sum of the ratio. And then repeat a similar process for the y's as well. And again, I'm not stressing this in the notes because most likely you're not going to memorize this formula. I personally don't have this formula memorized. But if you can understand the process, you might be able to duplicate that when the air test comes along. And that's it.